All right, let's go ahead and get started. Today we're doing 5.1 Introduction to Quadrilaterals. Our depth of knowledge is a level 3, and our learning target is I can classify a quadrilateral based upon the quadrilateral's properties. So, getting started. First off, a quadrilateral. A quadrilateral is all based upon its name. So the definition is just in its name, much like point-slope form or slope-intercept form, anything like that. So quad just means 4, like the quad muscle in your leg, or if you ride quads, you ride 4 wheels around. Quad refers to the amount of wheels, 4 wheels. So quad means 4, and then lateral means side. That's just a medical term that means side. So this is literally a 4-sided shape. So we're going to be learning a lot about 4-sided shapes. That's what our entire topic is going to be on for this chapter. So let's go ahead and jump right in. So first off, a quadrilateral is a polygon. Polygon just means many-sided shape. So it's a polygon with 4 sides, and interior angle sum is 360 degrees. Now we know that the interior angle sum is 360 degrees because if I draw a quadrilateral here, and it doesn't matter what quadrilateral you draw, I can even draw it a little bit uglier. So let me go ahead and draw this. Here's my quadrilateral. If I draw a quadrilateral, and I were to connect opposite angles together through a line segment called a diagonal. So if I'm connecting opposite angles together through a segment, that's called a diagonal. When I do that, that creates 2 triangles. Now within these triangles, we know that there's always 180 degrees per triangle. So therefore, if I have 2 triangles, that'd be 180 times 2, which is of course 360 degrees. So that's how we know that there's always going to be 360 degrees for the sum of all the angles within a quadrilateral. Now, quadrilaterals have a very unique family, and this is their family tree. So this is made up of a bunch of 4-sided figures. Now, some of those 4-sided figures are special. They have different properties, and they're all related to one another. So we have different types of special quadrilaterals, and that's what we're going to be focusing on today, specifically the properties that these quadrilaterals hold. So we're going to have a couple different families. We're going to have our parallelogram family, we're going to have our kite family, and we're going to have our trapezoid family. Each of these families are within the quadrilateral family, but they all have unique properties that their own families have themselves. So let's go ahead and start with parallelograms. And we're going to go more in depth with each of these terms as we go through. A parallelogram is just a quadrilateral with both pairs of opposite sides being parallel. That's where the parallel in parallelograms comes from. Next, underneath parallelograms, we have a shape that we should all be familiar with, and that is rectangles. So a rectangle is just a parallelogram with 4 right angles. So again, both pairs of opposite sides are parallel, but now we also know that it has 4 right angles for it to be a rectangle. Now, let's say that the angles aren't all right angles. However, the sides are all congruent. If that's the case, what we would have is a rhombus, where we don't have any right angles, but all 4 sides are the same. That would be a rhombus. Then the last one within the parallelogram family is, if it's a rhombus and a rectangle, it would be a square. So a square is just a parallelogram with 4 right angles and 4 congruent sides. That's all a square is. That is our parallelogram family. Now, all of these are going to go together. And in fact, you're going to notice, because when we create a Venn diagram here in a bit, underneath parallelograms, we're going to have rectangles, and we're going to have rhombi. So here's rectangles, here's rhombus, and where rectangles and rhombuses interlap, that will be our squares. So what you'll notice is that squares are going to hold all the properties of both rectangles and rhombuses. And further, it's going to hold all the properties of parallelograms. Also, rectangles will hold the properties of parallelograms, and rhombuses will hold the properties of parallelograms because they fall within that Venn diagram. However, parallelograms aren't going to hold the properties of a rectangle. If they do, then we'd classify it specifically as a rectangle. We always want to have the most specific name possible. So if it falls underneath square, I would call it a square because that's the most specific name. So these Venn diagrams do tell us a lot about which properties these specific quadrilaterals have. The next family that we're going to talk about is trapezoids. Trapezoids are just any quadrilateral, so again, it needs to have 4 sides, but this time only one pair of parallel sides. That's what makes a trapezoid a trapezoid. It has only one pair of parallel sides. Meanwhile, parallelograms had 2 pairs, so that's the main difference. Underneath trapezoids, we have isosceles trapezoids. The only difference between trapezoids and isosceles trapezoids is we'll still have one pair of parallel sides, except the other, I need to draw that a little bit better. Except the other pairs of sides, the sides that aren't parallel, are going to be congruent to each other, much like an isosceles triangle. We're going to have 2 legs that are congruent. And then the last shape that we have is a kite. A kite is in its own family. A kite is a quadrilateral with 2 pairs of consecutive sides being congruent. So consecutive just means one after the other. So both pairs of consecutive sides would be congruent. All right, let's go ahead and go more in depth with each of these specific special quadrilaterals. The first one that we'll do is parallelograms. But before we do that, just to make sure that we have quadrilaterals down, there are a few instances where a shape is no longer a quadrilateral, even if it has 4 sides. And that's if there's any open spaces in our shape. That would mean that's not a quadrilateral. We can't have any gaps. And we also can't have any curves. If you see a curve on a quadrilateral, that would mean that it's no longer a quadrilateral. It needs to be flat on all 4 sides. So if you see either of these, automatically know that that shape is not a quadrilateral, and more so it's not a specific or special quadrilateral at all. It's just a 4-sided figure, or we would just say it's a figure. So all the following shapes that we're about to cover are also quadrilaterals. They're all going to be 4-sided shapes. They're not all going to be parallelograms, but they'll all be 4-sided shapes. So let's go ahead and jump into parallelograms. The first one that we have is a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So that's what makes it a parallelogram by definition. Both pairs of opposite sides are parallel. We do have a symbol for parallelograms. It's the symbol right here. So oftentimes you see it written as parallelogram ABCD, or you'd also see it written as ABCD is a parallelogram. So you'll see it written both ways. Just make sure that you are comfortable with both notations. All right, so properties of parallelograms. So since we know that both pairs of opposite sides will be parallel, that'll be the same for any parallelogram that we go to, even the ones that are more specific. And that goes true with also all of the properties. All these properties will be used by all the rest of the special parallelograms that fall underneath this family. So the first property that we have is that opposite sides are congruent. If they're on opposite sides of the figure of the parallelogram, they'll be congruent to each other. The second thing that we know is opposite angles are congruent. So if we have angles that are on opposite sides of the figure, they will be congruent to each other as well. Next, we know that consecutive angles are supplementary. So again, consecutive just means one after the other. So if I'm moving around my figure, I'd see that both these angles, if I add them together, they would add to be 180 degrees. The reason for this, well, if I have 2 parallel lines, then the line that's connecting those 2 is a transversal line. And if that's the case, then I have angle relationships between these 2 green angles. First off, they're on the same side of our transversal. And secondly, they're inside our parallel lines. So they are same side interior angles. And we know anything same side is always supplementary. Now I can say the same thing with these bottom 2 angles. Same exact thing, they'd be supplementary. They add to be 180 because they're same side interior angles. So that is something that will always happen if you have a parallelogram. Lastly, the last property that we have is that diagonals bisect each other. Now diagonals are just the lines going through our figure. So diagonal starts at one angle, goes through the figure to the opposite angle. And you'll notice that we have 2 diagonals here. That will most often be the case with these. And just keep in mind it does make it into multiple triangles, and all of a sudden you have 4 triangles instead. So Just keep in mind, diagonals will create more triangles for you. Now, these diagonals do bisect each other, meaning that they're cutting each other perfectly in half. And that'll be the case for every single parallelogram. All right. Next up, after parallelogram, we're moving towards rectangles. Oops, that's weird. Rectangles. A rectangle is a parallelogram with one right angle. Now, if we have one right angle, that will imply that we have four right angles, and that's because it's a parallelogram. So it holds all the properties of a parallelogram, which means that if I have one right angle, opposite angles are congruent, so these will both be 90, and also consecutive angles are supplementary. Well, if one of those angles is 90, and they're supplementary, meaning they add to be 180, my other angle would also have to be 90, because 90 plus 90 is 180. So therefore, that will always be the case as well. One right angle turns it into four right angles. Now, some special things with rectangles. First off, the diagonals within a rectangle, they will always be congruent to each other. And that one's really important because it's used quite often. Diagonals will always be congruent within a rectangle. And that's the whole thing. Not part of it, but the entire thing. Further, diagonals will still bisect each other, so that will not change within a rectangle. Now, the angles aren't being bisected, just the segments. And since those segments are congruent, you can say, oh, both those divisions are also going to be congruent. Because again, the whole piece is congruent, so if both of them are being cut in half, then the pieces that are being cut in half are also all congruent to each other. All right, that's it for rectangles. Next up, we're going to go ahead and move on to rhombus. A rhombus is a parallelogram with four congruent sides, or all sides are congruent. Now, within a rhombus, make sure that these angles are not 90 degrees, because if it is 90 degrees, we have a more specific name for it. It doesn't mean that's not a rhombus anymore, but we just give it a more specific name. So first off, all four sides are congruent. If you see that ever, automatically know that that is a rhombus. The first property of a rhombus that we have is that diagonals are perpendicular bisectors. So they bisect each other at 90-degree angles. So as we can see, they're both being cut in half, both diagonals. And that makes sense because, again, they're parallelograms, and we know diagonals within parallelograms bisect each other. So that makes sense based upon it being a parallelogram. The main thing, though, that's different is that it's bisecting perpendicularly, meaning that they intersect at 90 degrees. Now, this opens up a lot of information for us because this will allow us to find missing angles very easily within these types of problems. And also, just seeing this, we can use Pythagorean's theorem quite often in order to find any missing sides. So, knowing that diagonals are perpendicular bisectors of each other will use a lot of good information and help you solve a lot of problems on this. The other property that we have for a rhombus is that diagonals bisect the angles. So the angles are also being cut in half by these diagonals. So you can very easily, if you're given the full angle, you can just cut it in half and you'd have both sides. So you can use that quite often in these problems as well. Rhombuses are pretty easy to solve for, just because you will be using a lot of Pythagorean's theorem. Again, that's a squared plus b squared equals c squared. And then you can always just use your sum of interior angles of a triangle, knowing that all three of these angles will add to be 180 in order to solve as well. All right, so next up, we've covered rectangles, rhombi, and parallelograms. The last thing that we have within the parallelogram family is the square. So the square is a parallelogram with four right angles and four congruent sides. It's important to note that a square is both a rhombus and a rectangle. So a square is going to have all the properties of a rhombus, all the properties of a rectangle, and since it is in the parallelogram family, it's going to have all the properties of a parallelogram. So rhombuses will have all the properties of a parallelogram, rectangles will have all the properties of a parallelogram, squares have all the properties of rhombi, rectangles, and parallelograms. So they also hold some unique properties of their own as well. But a lot of these are just the specifics of each special parallelogram that we've already covered. but we're just making sure that we're taking their own special properties for the square. So the first one that we have is that diagonals are congruent and perpendicular. Now, we know that they're congruent based upon it being a rectangle. We know they're perpendicular based upon it being a rhombus. So that means that these will be congruent, the entire thing, and perpendicular. Now further, since this is a parallelogram, we know that the diagonals bisect each other. So therefore, they're all going to be congruent to each other inside as well, all those pieces of the diagonal. And lastly, diagonals are angle bisectors as well. So that means that all these 90-degree angles are being split perfectly in half, making them 45 degrees each. So these are all special right triangles. These are all special 45, 45, 90 triangles, in fact. And again, if you don't remember 45, 45, 90, you don't need to know it for this test, but you will need to know it down the road. So very important to know anyway. So we know that our middle angle is 90. These two are 45 degrees. And then we have x, and x radical 2. So again, you can always find any missing values of a special right triangle, a 45, 45, 90 triangle, by setting up ratios. Now, again, it does also have all those other properties as well. So keep in mind, it's not just these 4 things, but it's all the properties of any parallelogram. Just parallelograms, not the trapezoids, not the kites, just parallelograms. All right, let's go ahead and move on. Next up, the following quadrilaterals are not parallelograms. So again, we're moving away from parallelograms now. We're going to be focusing on the things that are not parallelograms. The first one that we're going to talk about is the trapezoid. A trapezoid is a quadrilateral with only one pair of parallel sides. Only one pair. Now, as we can see, we have 2 different names on these trapezoids. We have the base, we have the legs. The things that will always be parallel will be the base. The bases are always parallel within trapezoids. The legs will never be parallel because it wouldn't make sense because by definition it's only one pair of parallel sides. If the legs are also parallel, that'd make it a parallelogram. So therefore legs cannot be parallel. That is the one property of trapezoids. Bases are parallel. Underneath trapezoids, we have isosceles trapezoids. Much like in an isosceles triangle, legs are congruent. So in an isosceles trapezoid, it's a trapezoid with 2 congruent legs, just like an isosceles triangle. Now again, bases will still be parallel, but the main thing here, what's unique, is that base angles are congruent. So again, base angles are found where the base and the legs meet. And we have 2 different types of base angles. We have lower base angles, which are found on the bottom, and upper base angles, which are found on the top. Now, lower base angles will always be congruent to each other, and upper base angles will always be congruent to each other. If I were to take a lower base angle and an upper base angle, they would be supplementary. So these 2 angles added together are supplementary, because again, these 2 bases are parallel by definition, which means that this leg is a transversal. So again, these 2 angles are same side interior angles, which means they'd be supplementary. Another important piece of isosceles trapezoids, and this is something that many people get mixed up, it does have a special property of rectangles in there. And that property is that the diagonals are still congruent. So the diagonals within this, the entire piece, those are still congruent in isosceles trapezoids. That's something that will not change. All right, the last type that we have to deal with is a kite. A kite is a quadrilateral with 2 pairs of consecutive sides congruent. So meaning one side right after the next. Those 2 are congruent. It's important to note that opposite sides are not congruent here. If they were, it'd be a parallelogram. So opposite sides are not congruent, it's consecutive sides, one after the next. And again, we have 2 pairs of that. So it's not just one pair, it's both pairs. With kites, there are some unique properties. The first one is that the diagonals are perpendicular and one is being bisected. So only one of those diagonals is being bisected. And it should be pretty clear when you draw it up which side it would be bisected. So make sure that you keep that in mind as you're looking at it. But more often than not, it'll be where the two different sizes of triangles meet. So I have a small size triangle down on the left side here, larger triangle on the right side. They meet at this diagonal, so I can see that it's being bisected. If I look at the upper triangle and the lower triangle, I can see that they're not different sizes. Those would be congruent triangles, and so this diagonal is not being bisected. It's only the one where the large triangle and the small triangle, the different size triangles, meet. The other unique property of this deals with the angles of that bisected diagonal. So these two angles, one on bottom, one on top. Those angles, exactly one pair of opposite angles, are congruent. And it's those pairs where it's the same pair of angles where the diagonal is being bisected. That will always be the case. Those pairs of angles will always be congruent. Again, a kite, trapezoids, they don't have the properties of parallelograms because they're not parallelograms. So they have their own unique properties. Squares, rhombi, rectangles, parallelograms, they all share those properties together. Of course, it gets more specific as you approach becoming a square. All right, so with all that information, we are finished for the day. If you guys have any questions, please let me know. But thank you guys so much for watching.